All right, let's go for it here. So let me actually put down 1.4 in case there is some people. 2.1, 2.2. Let's do that way. So give me section, give me problem.
2.2, 53. That's the last one.
2.2 online, number 9.
Online, okay. Put online number 9. We will go to that as well, no problem. Okay, and your problem is going to be different than my problem, but similar. Okay, any others? Ooh, then come talk to me after class or something. We'll do it that way. 53? 53. Okay, there's 53 2.1, 53 2.2, right? You want to make sure? Okay, any others? Going once, going twice.
Oh, 50, yeah, it wasn't 2.1, sorry.
That's 2.1?
Yeah,
Okay.
I was looking at the wrong thing.
Got it, okay.
It said 2.2 on here. And I was,
87 or 83 and 2.2.
87 and 83, 93. And in the back, 37. Okay? Okay, good now? Let's go for it. And I am going to ask you guys to quiet down as well here so people can hear what I'm saying all the way from the front over here. I'll raise my voice a little bit here. 2.1, let's go for it. Number 37 is what we're starting off with here. So y plus 3 squared plus y squared is equal to 9. And again, if I'm doing the wrong problem or something, tell me. I don't want to be doing the whole entire problem just to find out it's not the one you asked. All right, also, if I do make a mistake, which hardly ever happens, then tell me. Okay, so we have to solve, I guess, right? Going back to solve each equation. So this kind of weird. It's already somewhat in factored form, especially the y squared, but it's not set equal to 0. That's our problem. So here's what we're going to do. We're going to have to multiply it all out. There's a little fast way to do this piece, but you can also do FOIL. So y times y is y squared. Y times 3 is 3y. 3y times, that's that one, and then there's the 9. Or, so this guy will actually be 6y. We good there? Agreed? There's also a faster way to do it. Let me show you that way as we do the problem. You could also just take the y square value, square it, put a plus sign, same sign here, and you can just multiply the y and the 3 together. So 3y and then double that. All right, that makes 6y. Then take the 3 and square that. Remember, that's called a perfect square trinomial. It's those factored forms sorted backwards. Okay, the y squared also comes down, and then the 9 comes down. So the whole point here is set it equal to 0 and see if you can factor and solve. So y squared and y squared makes 2y squared. Got that already. This is a plus 6, and then I'm going to subtract the 9 here. When I subtract the 9 here, kind of funny. That goes away, that also goes away, so I'm left with this. So in this case, I'm going to factor out the y. Ooh, actually no, 2y even, right? 2y.
Yeah.
That was not a mistake.
That's just
I corrected myself real quick. Okay, so we got two things that are multiplying each other to give you 0. Therefore, I'm going to split it off as this or this. And again, you can skip that step as long as you know if you divide by 2, you're still going to get 0. If you subtract 3, you're going to get yourself a negative 3. And there are your two answers. All right, and then you guys tell me here if the back of the book is correct or not. Okay. All right, 37, gone. Awesome. Okay, 53 is the next one. An airplane gains altitude, the temperature outside the plane decreases. The relationship between temperature that's outside and the altitude is given by this little formula right here, which is kind of cool. Again, just some things to solve here. When the temperature on the ground is 70 degrees, so ground temperature plus the change in temperature according to altitude. Solve the equation below to find the altitude, which the temperature outside of the plane would be negative 35, and actually give it to you. You would say this right here, negative 35 goes here, and you want to be able to solve that right there. Kind of funny flying, let's see, from Texas to California this summer. I think the outside temperature was like negative 65 degrees when we were flying, and we were flying at a roughly like 650 miles an hour, which is kind of cool. That's fun, but outside temperature gets really, really, really cold when you go higher and higher. All right, subtract 70, and because these both are negative here, technically we're still adding, so how about a negative 105? So to that right there. Whew. All right, in this case, if you have a calculator handy, you probably do it with calculator. On this one here, you can do it the long way, but it's going to be really a long way. So 0.0035, and then we switch this around. First of all, the negatives drop off, so anybody 105 divided by 0.0035. Second? 30,000? I would agree. Okay, word problem here, so we have to answer it as a word problem here. So 30,000 feet, or 30,000 feet high, maybe would be a better choice there. Ah, forgot to put which problem we're doing. This should be problem number 53. Okay, jumping to, let's see, 8793, so 2.2, 87, put 93 here so I remember. All right, relationship between the number of calculators X and the company sells per day and the price P is given by this equation below. I think we saw something like that on the notes. It says, at what price should the calculators be sold if the daily revenue is to be $7,000? So there's a little missing equation here that's not here. And the revenue equation is always how many items you sold multiplied by the price that you sold them at. So that's what we need to plug in, and so we want to know what price. So eventually I want to know what P is. That's kind of the question here. So because of that, I want to get rid of X over here. I want everything in terms of revenue to price, or revenue in terms of price. So in this case, what we're going to do, we're going to just plug this guy in right into here. So now revenue becomes 1700 minus 100 P times P. All right, and then we also know how much we want. We want a daily revenue of $7,000. Okay, so that's what we really are looking for. So again, it's really factoring problem, just set to a business model here. Okay, so multiply in. How about 7,000 is equal to 1700p minus 100p squared. All right, it's probably easier to move the 7,000 over, but I'm going to have this little negative 100 here. So I don't have that. Let's move everything over this way. So I'm going to move the 100 over here, so that would be 100p squared. Move the 1700, it will give me a negative 1700p. 7,000 is already there, but now I have it set equal to 0. All right, greatest common factor. A 100, right? Okay, so let me go on to the next slide. So 100, it goes on the outside, p squared minus, you guys tell me here, what do we got here? 17, huh? Because that's 1700. So 17p and 70. Still set equal to 0. Then we're going to factor this down. Two numbers, multiply 70, add to negative 17. Anybody? Negative 7, negative 10 would do the trick. And again, you could do it the long way. The long way says 100 is equal to 0, or 7 minus p is equal to 0, or, I'm sorry, p minus 7 is equal to p minus 10 is equal to 0. And then this one we do is we just say that. That's not possible. 100 can't equal to 0. This one is going to be p is equal to 7. This is p is equal to 10. And the question is, does both of those numbers make sense? Yeah, they do. Since we're talking about price, that means you're looking at something just positive. As long as it's a positive number, you're good. You just can't have negative $3 for price. So it can't have really a price of 0 either, because that means you're not really selling anything. Okay, so in that case, at what price should the calculators be sold if the daily revenue is $7,000? So the calculators should be priced at $7 or $10. Okay, why the difference? Why in the world can you sell it for $7 and actually, or sell it for $10 and still get the same amount of daily revenue of 7,000? Is because something called demand, right? If something is a lower price, you'll have more people wanting to buy it. Something is a higher price, you have less. So really what you're looking at is you're looking at a graph that sort of does this. It goes up and it comes down. And let's see if we can put a few numbers on here. So you could, if you're selling it for $0, that means you're not really selling anything. If you sell a calculator for $10,885,000, no one's really going to buy that calculator. And so it's useless to go here either, right? Eventually there's going to be no desire. And so we said is if it's at $10, I'm sorry, it's $7 or at $10. So notice you got that two things, and they both will give you $7,000 as revenue. It's just how many you sell is going to be the difference. So you're going to sell a lot more at $7 than you're going to sell at $10, and it's all about revenue, not how many you sold. It's how much you sell times price. Okay. That's 87, jumping to 93. So 2.2, number 93. All right, the next exercise is physiology. A person's maximum heart rate, beats per minute, is found by subtracting his age in years from 220. Blah, 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 blah. So there's one formula. I'm not sure which one we're going to have to use here. So there's one formula here. This is maximum heart rate. A person's training heart rate in beats per minute is her resting heart rate plus 60% of the difference between her maximum and her resting. If the resting heart rate is an R and the maximum heart rate is M, then the formula, it has to be this. So Shar is 46 years old. Her daughter Sarah is 26 years old. If they both have a resting heart rate of 60 beats per minute, find the training heart rate for each. Oh boy. Okay, so two formulas to sort of deal with. And so notice we're going to have to use two formulas. So we're trying to get to T, right? We're trying to get to training heart rate. But we have everything in terms of just their ages. And so a little bit of work here just to sort of see what we can do. I'm going to take this guy and I'm going to substitute it right in for that right there. Because once I do that, I will have everything's in terms of training heart rate compared to age only. And then I also know about the resting heart rate. They both have a resting heart rate of 60. So let's plug that in. 0.06. Okay, this one's going to get a little complicated here. Let's see if we can do this here. This is going to be 200 minus A minus 60. Are we good there? That M became all this stuff right here. Again, so this is really just manipulating the formula to make it easier to plug in stuff. And we do that a lot in terms of business stuff here. So before we start calculating stuff here, 220 minus 60. Here, be okay with 160. And then simplifying some more. Anybody, let's see, 160 times 0.6. Let's see what that would be. Alright, gonna make me do it, okay, that's fine. 6 times 0 is 0, 6 times 6 is 36, and how about 96 is good because of the 1 decimal place. So 96 minus 0.6a, awesome. So tell me if we're okay here. 156 minus 0.6a. Ooh, a lot easier formula to deal with now. That's kind of what we're doing. We're manipulating two formulas to get us to 1. So now it's easy. So for char, her training heart rate is going to be 156 minus 0.6 times 46. All right, gonna make me do this again, I guess, huh? 36, that's going to be 24, 25, 26, 27, 27, so 27.6. So 156 subtract 27.6. Anybody can give me that one? One second, let me just look up something real quickly here. Let's see. Go for it. 128.4, maybe? 128.4. Okay, and Sarah's heart rate, 156 minus 0.6 times 26. You know, whatever you guys get. Okay. 140.4. Okay. So 140.4. Okay, and then of course we have to put units on it, and we got to write it in a single sense. So Shara's training heart rate is or should be 128.4, and we'll call it beats per minute. And the same thing here, Sarah's training heart rate, with a lot of chicken scratch here. Sarah's training heart rate is 140.4, and then BPM, if you like, beats per minute. A little abbreviation. So let me read it so you guys can know the chicken scratch here. Char's training heart rate is 128.4 beats per minute. Sarah's training heart rate is 140.4 beats per minute. All right, and again, the whole concept of what you really are testing really is getting down to this right here. Is can you work with two different formulas, manipulate it so that you get to a single formula. Okay, then we got some online we'll look at here. Uh, 2.2 number 9. Let's take a look at those here. All right, again, your number 9 is going to be a little different from my number 9, but that's okay. What else is there? Thought there's something here. Okay. Never mind. It should look like this. So ax plus 4 is equal to cx minus 2. We're trying to solve for x. But notice we're trying to solve for x, but we have an a variable and a c variable inside here as well. So how do you do all that? That's what we do. And then For me, it's more like why should I work more than I have to? So I'm going to do this here. Okay. Haha. Okay. All right, solving this here, we've got to solve for x. So we're going to take all the numbers that have x next to it, just move it all over to the left. But you can't put ax and cx together. They don't have the same variables. So you're going to write it as ax minus cx. Instead of the little plus 4 over here. Now since this is gone, you got yourself a minus 2. And then let's move everything over that does not have an x next to it. So that's gone. So how about ax minus cx is equal to negative 6. And then from here, here's a little problem here. I got two terms with x. In order to solve for x, I just have a single x. What we do is we factor. It's kind of like the greatest common factor, but it's just a common factor. And you got a minus c right there. All right, and then since we're almost done, a minus c is multiplying x, so therefore we're just going to divide that out. And so x is equal to negative 6 a minus c. Okay, good there. Well, I got to check if I'm right. Can't be doing stuff like that without checking. So I could write it like this, and if I wanted to, so negative 6 divided by, I have to put the a and the c underneath. There's two terms here, so I do have to open up a parenthesis for sure. So a minus c, close off that parenthesis, and I'm probably going to click the preview button as well. If think, okay, that is exactly what I got here. Yeah, that's cool. Okay, cool. Syntax okay. Everything's good. Cross our fingers. Whew, yes, we're good to go. Okay, good there.